Talk about section 2.3, long and synthetic division. And so synthetic division is something hopefully you guys will remember. And so long division is definitely a little bit more tedious. You can make a lot more mistakes, but it works for any polynomials that you want to divide. Synthetic division, we typically only do it. There are ways to do it when it's not like this, but we typically only do it when it's x minus c or x plus c. So x minus 3, you can't do it if the coefficient in front of x is anything other than a 1. So it can't be negative x, it can't be a 2x. It has to look like x plus a number or x minus a number. Just a reminder, so back in grade school, we divided 44, by 3. We took these numbers and we said, okay, what's something, in this case, what's a number that when I multiply it by 3, I'm going to get 4, something just a little bit less than that? Well, I could say 1. 1 times 3 is 3, and then we know we subtract. So 4 minus 3 gives you 1. This we drop down to get 4. Same thing. What times 3 would give you 14? Well, then that would be 4. And so then 4 times that would give you 12, so it's not quite there. And I subtract that, and I would get a remainder of 2. So there's a couple ways we could write that. We can write that as 44 equals 3 times 14 plus a remainder of 2. Sometimes that happens. Another way we can do that is we can rewrite that as 44 divided by 3 equals 14, which was what I got, plus my remainder over the number I'm dividing. So this divided by that is 14 and 2/3, or 14.6 repeat. Do the same thing here with 54 divided by 2. We're going to go through the same process there. So some number times 2, that's either 5 or close to 5. We can do 2 because that would give us 4. Subtract, bring that 4 down. So this would give you 1, then that's going to come there. And then in this case, 2 times 7 will give us 14. Subtract, and I get a remainder of 0. So this one divides evenly. So 54 is equal to 2 times 27 plus a remainder of 0, which I don't need. Or we could just say 54 divided by 2 is just simply 27 plus 0 over 2, which is just that. Because that divides evenly. And that's a big part, that when it divides evenly, you're not going to have a remainder. So this one, long division. So it says divide 6x to the third minus 19x to the second plus 16x minus 4, and we're going to divide it by x minus 2. So 6x cubed, I'm going to put that here, minus 19x squared plus 16x minus 4. Now, if any terms are missing, so for example, if I don't have an x to the second power, for example, at that point, I would have to write a 0. So if I don't have this x squared, I would write that as 0x squared. If I don't have an x, I'm going to write that as a 0x. Or if I don't have my constant term, always write that in as 0. So this can be a little bit tricky just to kind of, hopefully if you've seen it before, maybe a reminder. If not, this will be new. So we're basically saying what times x would give you 6x to the third? Well, let's worry about the x's. So some x times an x would give you x to the third. Well, that would be an x squared. Because we know that when we multiply these two things, we're going to add the exponents. So 2 plus 1 gives me, in this case, that 3 that we want. But now we have to get the numbers correct. So 1 times, so we're saying what number times this coefficient of 1 would give you 6? Well, that would be 6. So here's the thing. I got to take this 6x squared and times it by an x, which is 6x to the third. But I also have to do 6x squared and times it by this negative 2. Well, 6 times a negative 2 would give you a negative 12 or minus 12, and then x squared will bring it down. Now, once I do this, here's where people mess this up. We know we're going to subtract, but you have to be really careful when you actually subtract it. So as we saw in the example, we'll subtract. Here, 6x cubed minus 6x cubed, that cancels it out. Over here, I'm doing negative 19 minus a negative 12. So just kind of off to the side, I'll write this. Negative 19 minus, and then a negative 12. Minus a negative is really a plus, so that's going to give me a negative 7x squared. So that's where people go wrong typically with those problems when they're subtracting negatives and those things. So now these other guys are just going to drop down. So plus 16x minus 4. So let's start again. What times x is going to give you a negative 7x squared? Let's start with the x's. X times x will give you x squared, so I know this is going to be just an x. And then some number times 1 will give you a negative 7, so it's going to be a negative 7. So now I have to, almost like a distributed property, negative 7x times x, that's negative 7x squared. And then negative 7x times a negative 2, that's a plus 14x. And then now I'll subtract. So minus, and then this whole thing. So negative 7 minus a negative 7, that's really negative 7 plus 7. X squareds cancel. 16 minus 14, that'll give me 2x. And then bring down this minus 4. One more time. What times x would be 2x? Well, that would just be a 2. So 2 times x, that would be a 2x. But then you also have to do 2 times a negative 2. That'll give you a negative 4. And then we'll just do that one more time. So minus and then this. So 2x minus 2x cancels. Negative 4 minus that cancels. That means my remainder is 0. So you have a couple of ways that you can write that. You can say that this whole thing equals x minus 2 times this quadratic of 6x squared minus 7x plus 2. Another way that you can kind of, and that's typically the way to write it, or you could just say this divided by that and as a fraction is equal to this. Now, the remainder is 0, which means it divides evenly. That means x minus 2 is a factor. If x minus 2 is a factor, then if I set this equal to 0, what I divide by, you can just add 2. That means the 0 is going to be a positive 2. And you'll talk more about that when you're talking about the factor and remainder theorems. Okay, another one. This one's a little bit longer, so this is, notice how the order is all over the place. So we want to make sure everything's ordered correctly. So here, the highest exponent is 4, so I have 2x to the 4th. And then, so 2x to the 4th. And then the next one after that's going to be an x to the 3rd. So I'll have plus 4x to the 3rd minus 5x squared plus 3x and then minus 2. And then over here, you're going to have that x squared plus 2x and then minus 3. So now we'll do the same thing. What times x squared will give you an x to the 4th? Let's worry about the x's. X squared times x squared will give you an x to the 4th. And now I have to match up the numbers. What number times my coefficient of 1 would give me 2? Well, that would be a 2. So then I'm going to multiply. I have to multiply all three of these terms by 2x squared. Well, 2x squared times x squared, that's 2x to the 4th. And then 2x squared times a 2x, that would give you 4. And then the exponent of 1 plus that would be a 4x to the 3rd. And then lastly, 2x to the 2nd power times that, negative 3, that would give you a negative 6x squared. And then now, again, the confusing part is you have to subtract all these. So when I do this, 2x to the 4th minus 2x to the 4th cancels. 4x to the 3rd minus 4x to the 3rd, that also cancels. Now over here, you're doing negative 5 minus and then a negative 6. So again, negative 5 minus and then negative 6. Well, that turns into pluses here, so that just gives you a positive 1. So then this is just a 1x squared plus 3x minus 2, bring these other two down. So then I have that. I'm going to keep on going, so do it one more time. So something times x squared equals x squared. Well, that would just be a 1. So 1 times x squared is a 1x squared. Then 1 times 2x is a 2x. And then 1 times a negative 3 will give you a negative 3. And then minus, and then start simplifying. So x squared minus x squared cancels. 3x minus 2x, that's a 1x. And then negative 2 minus a negative 3, that's really like a negative 2 plus 3. That'll give you a plus 1. So this one does not divide evenly. So you could say that the answer, sometimes when you just say divide this by this, there's a couple of ways you can write that. You can write that as x squared plus 2x minus 3 times this 2x squared plus 1 and then plus that remainder. Or another way they like you to write it is once you do that, they say, okay, take what you got as your answer, which was 2x squared, 2x squared plus 1, and then they say take your remainder of x plus 1 and you're going to divide it by what you divided this whole thing by. So you take, okay, I divide it by this. This is what I got out. And then your remainder, whatever that is, you have to write it as divided by this. And that was kind of like the one example where we ended up getting 2/3 a couple of slides ago. All right, synthetic division is a lot nicer and easier. Same thing, if you're missing any of these terms, whatever your degree is, you got to have a couple other terms for that. If not, put a 0 in. First thing we need to do is we're going to put, I call it my corner number. It's always the opposite of this. Now, changing this from a -2 to a +2, or if it was a positive, change to negative, makes it a lot easier. It makes you able to add instead of subtracting. So now I'm just going to take all of these coefficients, 6, -19, 16, and then -4. I'm going to write them. If any of those are missing, then I have to put a 0 in place of this. This last number right here will be our remainder. So here's how it works. This first number drops down. With synthetic division, it's a series of, you're going to multiply and then you're going to add down. So I'm taking my corner number and I'm going to multiply it with this. So 2 times 6 gives me 12. That number goes here. So we're taking this corner number times this number, that gives me this, and then I add down. When I add those down, I get -7. I'm going to do it again. Take my corner number of 2 and times it by this -7. So 2 times a -7 gives you a -14. And then we're able to add these two numbers down. And that's why I changed the number to allow us to do this. So 16 plus a -14, that gives me a 2. Do it one more time. My corner number of 2 times this number of 2 is 4. We add down and we get 0. So that means that x minus 2 is a factor. It actually means that the 2 right here is a 0. It would cross, if you look at this graph on Desmos, this would cross at 2. Now the last little bit is, what is my answer here? So I have to take these numbers. This, what you get out, is always 1 degree less than we started with. We started with to the third. This is going to be an x squared. So this is going to be, these are coefficients, so 6x squared. And then that -7 will be 1 less, so it's -7x. And then that 2 will be my constant term. So this is my solution to that. And it has a remainder of 0. One more. On this example, notice that I have an x to the fourth, but I don't have an x to the third. So when I'm writing these numbers out, I'm going to have a 1x to the fourth. I'm going to have a 0x to the third, a -10x squared, a -2x, and then a 4. So I have to write in that 0, otherwise it's going to be wrong. This corner number is going to be the opposite of a +3, so it'll be a -3. So here we go. Bring this down. -3 times 1, that's -3. Add those down. 0 plus -3 is -3. -3 times this, -3, gives me 9. Add those two numbers down. I get -1. -3 times that will give me a +3. -2 plus 3 will give me 1. -3 times this one, that's -3, and that'll give me a 1. So the remainder is not 0. Remainder is not 0, which means this is not going to divide evenly, and that means that -3 is not going to be a solution. So I need to kind of write this based upon what I have here. So this would give me 1 degree less. So if this is an x to the fourth, this will be x to the third minus 3x squared minus 1x plus 1. And this ends up with a remainder of 1. So some people will write it like that. Another way to write it is x to the third minus 3x squared minus that x plus 1. And then you would take your remainder of 1 divided by what you divided the whole thing by. So we divided by an x plus 3. So then that's also your answer as well.